Okay, we're going to install the OpenSSH server, and here are the simple instructions. And let me get back to here. And so first we're going to do sudo apt update to make sure our system is updated. And let me put in the password, and hopefully it will update very quickly. And now we can install OpenSSH server, sudo apt install OpenSSH-server, and press enter. And we type in Y for yes, and it's installing everything that we need. And we can do sudo systemctl enable, systemctl status SSH, and that checks the status of it, and we can actually have it enabled every time we log in. So sudo systemctl system control enable SSH, and this will make sure it's going on every time your machine is on. And let's demonstrate the power of SSH. Now, to do that, we can compare that to telnet. So before we run telnet, let's make sure that telnet is still running, and it is running. As you can see, I did systemctl status inetd. That is to make sure that the telnet process is going, and you can see that it is active running. Let me press Q to get out of there. And again, let me start my Windows. Hopefully everyone can see this. This is my Windows virtual OS. Let me log into my virtual OS, and let me go to my Wireshark and begin capturing. And then what I will do is telnet into my system, and then SSH into my system. Here we go. And Wireshark is slowly but surely opening up, and wondering if I should pause the video because this is taking a while, but here we go. The virtualized servers will always take longer, but we are starting our capture, and I'm shrinking this. And let me go to PowerShell. Here I go. And again, this is taking a little bit because I probably, to make sure I don't run out of power while I'm doing this, I'm going to go ahead and plug my machine in. There we go. And come on. All right, there we go. So telnet, and it connects into it. We have my username and my password, and we have logged into my server via telnet. And I can actually press up on the keyboard, and we can see some of the commands I tried before, and when it didn't work. But the point is that we were capturing it, and now that we've captured it, we can end capturing it. We can go to stop, and we can go to a TCP port and filter only the 23, and press enter to isolate port 23. And here we have done it here. We can go and analyze, follow, and TCP stream, and we can see that my login was discovered. Now let's try to do the same thing for SSH. 1 second, and we can quit without saving, and we'll do the same thing except for SSH. Okay, everyone, two things about this. I wanted to do the perspective, or I wanted to partition the screen such that you had the best vantage point so you can read the text. So let me go over this with you. This window is the Windows client, and this window represents the Linux server. Now this server will be running SSH, or is running SSH, and because it is configured as a system, I'm going to say process, or as a status or systemctl process, that means it runs in the background no matter what. And on this side, of course, I just wanted to walk you through the thought process. So the first thing we want to do is ping the IP address of the Linux box to make sure that you can actually reach it via layer 3 in the first place. And so I tried SSH at first, and it didn't work, and I realized I hadn't pinged this server yet. So let me go ahead and figure out what the issue was. So I did sudo ifconfig, and lo and behold, as you recall, that my address was something else, my IP address, and now it has changed to 192.168.1.152. So the network connection is a bridged connection to my network. Thus, it's going to it's going to have an IP address as if it was switched, if it was on a switched connection to my network. So it's going to have an IP address within the LAN, but the fourth octet changed to 152. And I recall that last night and the night before I installed a new, I bought a gaming PC, and I just installed it last night. I must have ordered it like 4 weeks ago, and it just came yesterday. And so it took me, it was so heavy. It was like almost the size of a 3D printer. That's how big the computer is. Anyways, it does have the new RTX 5090 in it. And when I installed it, it grabbed a DHCP IP address, and I think it reset everyone, others that weren't online at the time. So because of that, my IP address changed. So the first thing we're going to have to do is we're going to have to ping. This is on this side, ping 192.168.1.152 to make sure we can get to it via layer 3. And we can, okay? And we're going to say clear screen again, and we can actually try to SSH. Now, as you can see, I already had this command set up, and I did that for ease. So we have SSH and then space and then the username that you want to SSH into at 192.168.1.152. Now, that is different than the telnet command that we use. In the telnet command, we just say telnet and then the destination IP or domain name, okay? It's just a little bit different for SSH. In this construction or configuration, you can do username at destination IP address. Now, something a little bit different happens on this side because SSH rides on encryption and hashing. So even before it connects to it successfully, it's going to request that you get the fingerprint of the server internalized in the internalized into the SSH cache of the client, and that is to ensure that the destination is in fact the destination. It's not another destination that's masking it. So for example, if you go to chase.com, you want to make sure it's actually chase.com and not an imposter through like DNS spoofing or something like that. That being said, let's get along. Let's press enter, and it's going to say the fingerprint is SSH is now SHA-256 is a hashing encryption algorithm, and this is the hash algorithm of that server, okay? And do you want to, let's see, are you sure? Sorry, this print is so small that your professor actually has to put on his reading glasses, and let me do that now. Are you sure you want to continue connecting? And of course, you're gonna say yes, and permanently added 192.168.1.152 to the list of known hosts. And then it's going to ask for Jason's password, and let me put it in. And guess what? We are now connected to SSH, connected to the server via SSH. And I'm going to say quit, or I'm going to say exit, and that closes the SSH connection. It's not quit, it is exit. Let me type in CLS to get to remove all that from the screen. Now I'm going to show you the difference from a cybersecurity standpoint of Telnet versus SSH. I'm going to go to Wireshark, and let me get my reading glasses on. And I do apologize if those of you can't see this. You'll just have to get real close to the screen. I'm going to press start, and my actual physical host is going to ask me for my password because it wants my credentials. So now we will go to SSH here, and it's asking me for my password again, and there we go. I'm now logged back in, and from the capturing standpoint, we're done. I'm just going to, let me bring this over here. I'm just going to press stop, and we can go to the drop-down box here. And again, I do apologize, this is so small. Let me get to the drop-down box, and instead of TCP dot port equals 23, since SSH is port 22, we'll change the 23 to a 22, and then we will press enter to filter out all the port 22s, and we can get this one here. This is the protocol SSH v2, and we can see that, my apologies, we can just click on this once and then go to go to analyze and then follow and then TCP stream, and we can see that unlike Telnet, we could not successfully we can capture the SSH login information, but we cannot decrypt it so that it makes any sense. So the main difference is that Telnet, the credentials are sent over the network in plain text, and SSH is sent through the network via an encrypted message. So that's why SSH is infinitely more secure than Telnet, and you as a system administrator have to know the difference.